Good morning, students. Welcome to our electrical and electronics measuring instruments topic. Today we are going to cover network theorems. In that, voltage and current sources, how these are conversion takes place, voltage source to current source, vice versa. As you see, this is a one source generally used in our laboratories. In calculation of voltage current in a given small PCB circuits. We can say this is a RPS, regulated power supply. Now, what is inside the regulated power supply? Let us see in details. Now, today our topic is, on completion of this topic, you would be able to know what do you mean by ideal voltage source and non-ideal voltage source, differences between ideal and real voltage sources. Similarly, what do you mean by ideal current source, non-ideal current sources, differences between ideal and real current sources used in our electrical networks. Then how to convert from voltage source to current source to voltage sources for reduction of networks for our convenience purpose. Okay, so these are the topics we are going to cover. Now, known to unknown. So we have learnt that a driving force is necessary to establish a current source through a conductor. The driving force is called electromotive force or potential. What is the meaning? In first year level, you have learnt that okay, before going to this one, let us ఈరోజు కార్తీక పౌర్ణమి సందర్భంగా మీ అందరికీ కార్తీక పౌర్ణమి శుభాకాంక్షలు. Now, let us see it. For example, there is a incandescent lamp in my house. There is a lamp. I connected through a supply here. It's connected here. Now, what will happen? If circuit is opened, battery is connected here. For example, a DC battery, where it has the positive charges on one plate, where it has the negative charges, charge particles. Now, circuit is opened, the current is open. Once circuit is closed, the current has to flow through the circuit. At the same time, from our lamp and is coming here. What are the charge particles present on a terminals has to move towards our load circuit. That requires some force is required here that has to drive the charge particles towards the load. This driving charge we can say it as a EMF, electromotive force. If electromotive force is not present in this source, whatever the charged particles unable to move in a circuit because there is a high resistance here. The charged particles has to move from source to load. We require some electromotive force is required. That electromotive force we can say is a voltage. A device capable of providing this force may be called voltage source. For example, this one battery, or you can say it is a generator set. Okay, that means here whatever the charged particles has to move from this place to source to this one. That means here is the source, here is the load. It is connected here. It has to flow. This is the electromotive force. Then the current will flows. Let me ask one question to you. How do you are getting a current to your home? Daily you are using tube lights, fans, mixies, refrigerators, even televisions and TVs. So, how we are going to get this electricity? Yes. So, what are the sources of energy for your domestic house? Will you tell anyone? As electrical students, you should know what are the energy sources available. Those are you are utilizing daily. What are the sources generally? Yes, you can see it. That is the bulk energy generating stations. You can see here what are the sources. That is the mainly. So this is a TPS. What do you mean the TPS? This is the TPS, thermal power station. It generates a large amount of the electricity at nearby coal mines. And sometimes we can use another station, that is HPS, hydro power station. Rainy season water stored in a dam, that water is used as generating the electricity by using hydropower plants nearby here dam. This is also generates a bulk power to the consumers, but it is dependent upon the season. Rainy season it generates more electricity. Now these are the season, and another source also what is this one? You can see it. Yes, this is a solar photovoltaic cells. Solar energy. This also nowadays we are using this type of the solar energy also very familiar. And not only this one, we can use by using the diesel also, that is a MG diesel power station. So this is also one type of the diesel. So you can generate electricity from thermal power station, you can generate from the hydropower station, you can generate a non-conventional energy sources, that may be solar, that may be wind, that may be geothermal, that may be chemical, any type of the energy sources, and that may be diesel MG sets. You can observe in front of your shopping malls. So these are the different energy sources developed and connected one center point. We can say this is a power grid. From power grid we are transmitting to the different places. From south to north, west to east, we are transmitting the electrical energy from different energy sources. These are the plants generally used for generating the bulk energy in megawatts. Okay. Now, you can see it for a small generation, this is the megawatts. In kilowatts, in watts, we are also generating with help of other sources, available stored sources. What are those? You can see, what is this one? These are the different types of sources. Stored storage, those are the generating plants. From that generating plants, whatever the energy is stored in some compartment, some device, those are known as the batteries. You are very familiar. What is this one? Cell phone battery. These are the another type of the batteries. You can see your vehicle battery, 2-wheelers and 4-wheelers. This is a lithium ion battery. This is a button type cells you can observe in systems or even watch. These are the different the cells. It can be used for rechargeable cells, and these are the dry cells, different of cells. It can store the energy, 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 it can store the energy in the form of the chemical energy. Once we required this, whatever the chemical energy in this one, we convert to the electrical energy for our small circuits. Okay, so small powers, we can batteries, energy sets. So you might observe in front of shopping malls, and in domestic also UPS we are going to use this one. So these are the different energy sources generally used in our electrical field to run our motors and machines and different devices. Now let us classify the energy sources based on electrical circuit operation. So let us see the types of sources. The sources are mainly classified into two types. One is a voltage source and current source. The voltage source, that is a voltage across the 2 points. Current sources, the current in a closed circuit. The voltage source is further classified into ideal voltage source and practical voltage source. Similarly, current sources, ideal current sources and practical current sources. You may be some confused state. What do you mean by ideal voltage source and practical voltage source? Let me give one example. Here the ideal voltage, ideal means there is no losses inside, it is a perfect. Rahul is the best, the person, there is no deficiencies inside, it is always number 1, perfect. But practically it may not be Mr. Perfect, that is the ideal voltage source, but actually there is some defects inside, small defects. So that is a practical voltage sources. Let me give you one analysis just in domestic. What is that one? So for example, now you can take here. Let's, for example, so here is your father working in a small office. Every month you will get the salary. if your father takes salary from office, okay, now the same salary is given to your home, to your mother, okay, to your mother. Whatever the salary is taken from the office, directly total amount will give to the your mother. Your mother is happy. This is the ideal case. Ideal case. That means there is no misuse of amount on the way, or not any debits, loans in office. Now in this case your father is the ideal father, but practically what will happen? Now your father taken loan, GPF loan or loan from office for GPF loan, and he has to pay some proportional tax, PF. He has to pay some income tax, proportional tax, income tax, GPF, APGLA, different some savings also, savings. So these are the amount, we can say these are deductions. These are the compulsory deductions in office before hand over to the amount to your father. Now previous cases, whatever the gross salary, so that means if for example your 25,000. Previous case, whatever the 25,000 gross salary is given to your mother. Okay, your mother is happy. But actually what will happen in office? Now 25,000, from the 25,000 he has to pay the professional tax, some amount, some 200 rupees or 300 rupees. Income tax he has to pay the, for example 2,000. GPF loan he has to pay the, suppose 3,000. This 3,000, this is 1,000 and PF 500 for example. So 3,500 he has to deduct from his salary. Then what is the salary? The accountant will give to your father, the amount is now, what is the amount? 25,000 minus 3,500 rupees will give to your father. Then what is the amount? 21,500 rupees will take, that will give to your mother. Now your mother is now waiting and post date. Now she will take the money but reduce the amount. So in this case what will happen? Your father is not ideal father. So because his actually gross salary is 25,000, but instead of 25,000 now he has given only 21,500 rupees only. So remaining the savings 3,500 amount is a compulsory deductions in office itself. We cannot avoid those. This is a practical situation. So this is known as a non-ideal condition, or we can say the practical condition. Similarly, our batteries also ideal condition and non-ideal condition. Okay, so this is some similarity. When your father is getting the total gross salary from his account, may not be given directly to his total amount. After deductions, that amount may be handed over to your father. that same is given to your mother. So that is a practical. So what is in between? There is a reductions. We cannot avoid those. So the practical situation. Similarly, even in our circuit also, we are going to sources are two types. One ideal sources, another is the practical sources, or we can say the non-ideal sources. Okay. So what are those characteristics? We will see. Now you can see. Now the types of sources further classified into, here you can see it, direct sources and alternative sources. That means here DC and AC, DC sources and AC sources. Students, please remember that in all electronic circuits, electronics generally used only DC supply. So that's why I concentrate on DC sources. So DC sources are further classified. One is the independent voltage source and current source. Independent, it does not depend on any other factors, whereas other sources are dependent voltage or current sources. It depends upon the other factors. There is a condition here. So it is not independent, it is depend on other factors. If other factors success, then it will give the voltage or current based on that factors. Okay. Whereas the independent source, it is directly will give the voltage and current. It does not depend upon the other factors. Now the dependent source further classified into these four types. What are those? Here you can see it, the voltage controlled and voltage source. Here the voltage source is controlled with the voltage. Here the current source is controlled with voltage. That means voltage controlled current source. Now here we can see the current controlled voltage source, and another here is the current controlled current source. These are the further classified. So these will come in networks. Okay. The DC sources are further classified into dependent voltage or current sources and independent sources. So here the dependent sources further classified into, here we are going to control voltage or current. So here voltage control source with voltage source, current sources. Current control sources are voltage source and current source. Okay. So these are the different types of the sources. Now let us see what are the main sources. So in our circuits, so we are going to get only one simple. What do you mean? This is a echo battery. So similarly we are going to say voltage source and current source. Now let us see first voltage sources. What is the ideal voltage source? What is the practical voltage source? What is the difference between ideal voltage source and practical non-ideal voltage sources? Its characteristics we will see. Okay. After that we are going to see what is the current source and what is the non-ideal current sources. It's a very easy topic and interesting topic. You can see it. Now, so further the voltage sources, we can see this further voltage sources. One is the ideal voltage sources, another is the non-ideal sources. Let us see this one. Okay. Now, here voltage sources. The voltage sources further classified into two types. One is the ideal and another is the non-ideal. Ideal means your father is the ideal father, whatever the salary is taken directly given to your mother. Whereas non-ideal sources, but practically he has its own some problems. So whatever the is that is salary is given to your mother after deductions. Now we can see what is the, where it will act as a ideal source, where it will act as a non-ideal source. Okay, this is a voltage sources. Now voltage sources are ideal voltage sources, and you can see here this is the example. So where it has a battery, this is your mother, this is your father. Okay, now what will happen? So here the internal resistance or internal resistance, there is no deductions, there is no GPF, there is no proportional tax, there is no income tax, or is not taken any loan from his friends also. Then so Rn, internal resistance, equal to 0. So here Rn is equal to internal resistance, that is equal to 0. And whatever the source, that is source is going to the, just go to the load. Where is the load? Load is your mother. Now whatever the source, applied voltage is equal, this father voltage is equal to terminal voltage Vt, Vt is your mother. There is no drop in between, there is no consuming component, there is no bad habits here, there is no deductions path. So that means whatever the sources, here source, and is given directly to the your load, that is equal to Vt terminal voltage, here is a Vs source voltage. Both are connected in parallel. In between there is no internal resistance, there is no other components. So this case is, we can see the ideal voltage source. Here what are the 1.5? You can see the 1.5 volts, same 1.5 volts appear across the load. Now what is the non-ideal source? So in this case we are assuming that there is a R internal is equal some resistance, for example 1 ohm. That means here whatever your father in between, so what will happen? Some internal resistance, this is a in office, then is given to your mother here. So what will happen? This resistance has to take internal resistance, load resistance. This voltage has to supply to this and this one. This drop plus this drop is equal, for example, small v1, capital V2. Then what is the voltage? Applied voltage is equal to your father is equal to small deductions plus your mother load. So whatever that may be, it may be small value. So for example here 1.5 volts, this is a 1.5 volts, your father volts. Here your mother is receiving the 1.45 volts only. That means 0.05 volts is taken by the this internal resistance drop. That is known as a non-ideal voltage sources. Here this is not equal to 0. There is a small amount of the resistance, that is known as the internal resistance. We cannot avoid this thing. Just like the proportional tax is the proportionally he is doing job, he has to pay the proportional tax. Savings you leave it, but he has to pay that small amount. That is not the non-ideal sources. Dear students, don't confuse it. It is a very simple circuit. Okay. Now ideal source is two terminal sources. You can see here. What is the one? You can see what is the ideal sources? Here ideal sources is a, this is known as the, for example, plus minus. An ideal source is two terminals element in which the voltage is constant and independent of the current flows through the its terminals to the load. Here there is a load. This is known as a VT, terminal voltage. This is called Vs. Now this is the resistance. As you know that the current flowing in the circuit I depend upon the resistance, load resistance. If load resistance increases as per Ohm's law, the resistance here, what will happen? So if resistance increased, current will decrease. Okay, depending on the load, the current changes. So I and R inversely proportional. Then initially, suppose two terminals voltage here. What are the Vs is equal to, for example, 12 volts. Then here also what are the voltage applied is the 12 volts up here, because both are in parallel connection. Source voltage is equal to the terminal voltage. Now what is the current now? Here for example, this source is equal to, here we can take the, so for example 10 ohms. What is the current? Current is equal, I is equal V by R. What is the V by R? V is equal to 12, R is equal to how much? 10, that is equal 1.2 amperes will flow through the circuit. If 1.2 amperes flowing through the circuit, the terminal voltage, if measured with a voltmeter, same has the 12 volts only, similar to the source voltage. Okay. Now here load is increased further. Now instead of 1.2 amperes, now what will happen? The load is here decreased, current is resistance decreased, load is increased. Now the current instead of 1.2, now current may be suppose 3 amperes. Then measure the voltage. When it is going 3 amperes, measure this one. Even then the voltmeter will shows the 12 volts only. Vs is equal to Vt. If increase the further current 5 amperes, then measure the what is the voltage here. Then even then this voltage also 12 volts only. Further 6 amperes, what is the voltage here? 12 volts only. That means from 1.2 amperes, 6 amperes, the variation of the current increases independent of the load. The voltage maintain the constant 12 volts, that is equal to the source voltage. If the source voltage and terminal voltage are equal independent of variation of current in a load, those sources are known as the ideal voltage source. Dear students, don't confuse. So once I am going to explain here what will happen. This is a source, this is a resistance. Now in this voltage Vs, this is equal, we can say the Vt, terminal voltage. The Vs is equal to Vt irrespective of load current. Those sources are known as the ideal voltage sources. An ideal source is a two terminal sources element in which the voltage is constant, it maintains the constant voltage irrespective of load on the circuit. Whether load may be increased or decreased, the current may be increased or decreased, but whatever the source voltage equal to the terminal voltage, that situation, that terminal, that source, we can say it is a constant or ideal voltage source. That means if you draw the characteristics of diagram, so we are going to draw it. What has happened here? Now if you draw the line, so you can take the current here, you can take the voltage. Initially 0 current. If there is no current, what will happen? So simply here is the even current is, there is no current in the, that is simply open circuit. The voltage is the same 12 volts here. If load is increased 1.2 amperes, it is all same. 3 amperes, it is also same. 5 amperes, it is also same. 6 amperes, it is also same. That means here the current increased from 1.2 to 6 amperes. The voltage is maintained constant. So you can see the anywhere time pass t or y. So it is maintained the constant irrespective of the current value. Current may be 0, current may be higher value, but it maintains the constant. This type of the situation consists in a element. Those element is known as the ideal voltage source. Okay. So that means the voltage whatever the 12 volts, here also 12 volts, not it is dropped to the 11 volts, it is not dropped. Whatever the gross salary is given by your officer to your father, that is given to your mother, 25,000, 25,000, ideal source. Okay. But actually it is not practical, as we have seen, is always reduced by something less. Now in practically what will happen? In practically, so some initially 12 volts, then when it comes to some stage, the GPF, some IT and savings all will goes here. This is the removed, that may be 1 volts. So here going to 11 volts. So this is a real condition. If current increases, then voltage reduced further. Initially there is no current, open circuit, 12, it will show the 12 volts. When load increases, then a drop may be occurred in the internal resistance. At the final, the terminal voltage is reduced to the 11 volts only. That means what is the difference? 1 volts difference between the starting to ending. So this is a practical voltage source. What is the reason? Due to the internal resistance. How we cannot, can you avoid the internal resistance? No, because the property of the materials. So what are the source? In first year level you have seen that batteries, it has a lead peroxide. H2SO4 is a electrolyte, and due to the during the process, the charge particles move the terminals, ions and cations and anions moving towards the positive terminal, negative terminals. And this process, those it act as a some resistance. We can say that is the internal resistance. We cannot avoid that internal resistance. Okay, but as per as possible, we are going to keep this internal resistance should be as possible as minimum. That is our aim. But we cannot avoid 0. If it is a 0, that is the ideal source, but we cannot get practically. Okay, now. So this is the ideal voltages as we have seen. What is this one? Here, what is the voltage? What is the AB? This is the terminal voltage, load voltage. This is a source voltage. So this voltage initially you can see. So same voltage is maintained here. So whether time or current. So first time in hours, first hour, second hour, third hour, it is maintained the same constant voltage. Okay. So it is that the voltage source or generator whose output voltage remains absolutely constant whatever the change in load current. Such a voltage source must possess a 0 internal resistance, so that internal voltage drop is 0. So I have seen, so R internal, that is equal Rn is equal 0. That means whatever the deductions in your father office should be 0, then we are going to get, so the total gross salary equal to net salary. Here we assumed there is no deductions. Okay. Now Thus, the output voltage provided by it remains unchanged or it may be constant. Okay, this is we are assumed this is a constant, that is the ideal voltage source. There is no losses, there is no resistance inside. Whatever the source voltage equal to terminal voltage irrespective of load changes or irrespective of current changes. The current may be changed, but our voltage may be maintained. So that's why it is a constant voltage. Constant voltage source means it will maintain the constant voltage irrespective of current changes. Vice versa. What is the constant current sources? It maintains the constant current through the circuit independent of the voltage changes. One is the constant, one other is a variable. Suppose constant voltage should be maintained when changes in the current. Okay, so this is one thing. However, such ideal voltage source cannot be obtained in practice, but a smaller the internal resistance of a voltage source, closer it comes to an ideal source. This is better understood with an example. We can take the one practical. Here we can take it. Here what is this? E is the energy sources, voltage sources. E small r is the internal resistance, and this is the A and B is the load connected here. Load is variable. Based on the load variable, the current flowing through circuit from source to load is changes. Okay. Now, let us consider the circuit as shown. Assume the voltage supplied by the battery as 6 volts. Here E is equal 6 volts and internal resistance is as 0.005, very less internal resistance. Small r is equal 0.008, 5 volts. Okay. Here what is the value is given? 6 volts is the source voltage, and small r is equal 0.005 volts, because that should be series connector, that should be keep as possible as minimum. If you are going to increase that value, whatever your generated source is consumed itself only. Okay. Now, consider two cases for that battery. So, what is the battery is given here? So, here battery is given such a way that now the internal resistance is connected here and here connected to one load. Okay, load. First case, when the supplying no current, that means here what will happen? So, we are not connected any load, that means just you remove the load. Okay, first case we are going to see. So, this is a source, okay, this is the internal resistance, this is connected here, and here is the Vt, this is called E, that is called small r, and here I am not connected the any load here. Then what will happen? So, at no load condition, load is open condition. So, V0, that is called Vt or V0 output voltage is equal 6 volts. E is equal to 6 here and V out is equal to 6 volts. Okay. So, E is equal to 6, V out is equal to both are, because no current is passing through the this one, current is not passing, no drop occurred here, no internal drop here, resistance as per KCL, circuit is opened. Now, in second case, in this case you can see here. Now, what is happened? If this is connected to the load, nearly 100 amperes current is flowing. So, 100 amperes. Okay. What is the resistance here? 0.005 ohms. Now, what is the drop here? Drop is equal V is equal I into R. So, what is the I? I is 100 amperes. What is the R? R is equal to this value. So, multiply. So, the 100 into 0.005, then we are going to get it 0.5 volts drop. So, this is a 0.5 volts. That means drop is taken place in between due to the internal resistance is a 0.5 volts. Now here is a 6 volts. Now this is a Vt. So what is the value? 6 is the source, this is the drop, this is the drop. By applying the KVL in a closed loop, sum of the sources is called sum of the drops. Here drop is a V out plus this is the internal drop. So 6 minus 0.5, we are going to 5.5 volts appear as a output voltage. That is equal V out is equal 5.5 volts, not 6 volts practically. Okay, that means 0.5 volts is dropped from current from 0 to 100 amperes variation. I think this is a small variation. So practically it is an ideal source. Okay, 100 amperes changing from 0 amperes to 100 amperes, the maximum voltage variation, that is means here the voltage, if you draw the diagram, so we are going to get it. So it's small, it's what is the value? It's 6 volts, but we are going to the small drop, drooping characteristics, 0.5 volts. Almost it equal to the ideal source. Okay, now here the voltage drop of 0.5 volts is taking place when it is supplying a load current of 100 amperes. Obviously, an output voltage of 5.5 minus 6 volts can be considered a constant as compared to wide variation in load current from 0 amperes to 100 amperes. Okay, hence it may be treated as a ideal source. So, but you can see small drop we are taken as assumed as a ideal source. So non-ideal voltage source you can see outside, practically Exide and Umron, different of the batteries you can observe for the vehicles, 12 volts, 9 volts, different source. When there is a large variation of the output voltage for a small or moderate change in current. So if the here from 0 to 100 amperes change in voltage only 0.5 volts, but instead of 0.5 volts, if there is a 3 volts or 4 volts, or it may be 2 volts, then what will happen? The variation of the voltage is more. At that situation, those are known as a non-ideal voltage sources. Okay, such a voltage source may be called non-ideal real type voltage sources. You can see here what will happen. So in this case, so here is the actually voltage, but here is the voltage. The gap between this is known as the drop. If drop is significantly more, then those sources we can say is a non-ideal sources. If this drop is significantly very less as compared to the change in current, then we can say is the ideal sources, as we studied in just now. Okay, so this is the one thing you have to remember. So what will happen? This voltage source may not be equal to this source. So what will happen? There is a drop occurred here significantly. If this drop is very less comparing to a large variation of the current, then we can say ideal source. If not, then we can say non-ideal sources. Okay, so these are the one thing follow. In other words, if the internal resistance of such a voltage source will not 0 or a small value, rather than it will be a high value. So in the previous case when the 0.005, instead of 0.05, if you are seeing the 0.5, what will happen? So what is the drop? Nearly, so 0.5 into 100 amperes. So 5 volts we are going to get nearly. Okay, so that is the 0.5 into 100, nearly 50 volts. That is the undesirable things. Okay, now coming to the voltage source, current source. What we have seen? The voltage source, ideal voltage source, non-ideal voltage source. Ideal voltage source, what is the ideal? So it is it maintains its terminal voltage, output voltage constant irrespective of variation of load current in the circuit. That is known as the ideal voltage source. Okay. Now, coming to the ideal current source. In this case, what is the ideal current source? In this case, the current is maintained constant irrespective of voltage changes in the circuit. The voltage may be changed, but current should be maintained constant. Those are known as the constant current sources. Okay. An ideal current source, similar to previous one. Ideal current source is a two-terminal element in which the current is completely independent of the voltage across its terminals. If the voltage changes, terminal voltage changes, it has to maintain the constant current. That is known as the ideal current source. Okay. So, for example, you can take it here a definition. So, what will happen here? Whatever the current source indicated by, so what plus minus indicated by the voltage source, but current source indicated with this arrow. This is a current source. Okay, current source. The current source is connected to the load. Here, whatever the current comes flowing through this one, then automatically V out changes by changing this one. But it has to maintain the current is a constant irrespective of change in voltage. That is called R. R into I changes value. If change in this value the voltage, but it maintain the constant current, that is a constant, then we can say it is a constant current source. So, that purpose we are going to use some I resistance in parallel to this one. Okay. So, now let us see first one. It is that voltage source or generator whose internal resistance is infinity. That means here what is the meaning? The current source connected to resistance, the load, we can see the RL, we can see this is the VL load or V out, we can say the V out, this is the IS. Now, whatever the current is flowing here is the I1. This V out, if you are taking that one, so here I am going to convert resistance, here internal resistance should be, here resistance should be very, very high, that should be infinity. Otherwise, what will happen? The current is flowing here. So, if low resistance, the current is closed in here only. Instead of it has to flow this direction. So, if I keep high resistance across this terminal, then what will happen? So, the current will directly flow through the load. If the internal resistance or internal Rn is equal to infinity, then we can say it is a current source. It is that voltage source or generator whose internal resistance is infinity. So, it is not connected in series previously, it is connected in parallel across the source. Those sources are known as a current source. Okay. Now, we can see here. So, internal resistance is the seat infinity and the current is the 100 milliamperes flowing through the source, and here is the load is connected, 8 ohms resistance connected. Such a source must possess a very high internal resistance as compared to that of the external load resistance. That means here RL, this value, for example 100 ohms, then so Rn internal resistance, that should be nearly so 100 kilo ohms, simple ohms in the kilo ohms. That means a very, very high resistance, or kilo ohms or mega ohms also sometimes. That is required in a ideal current source. Thus, the output current provided by it remains unchanged or constant if the load changes. You can see as diagram. What has happened? So, here the current source, initially the current is this one, and at the time passes current is this one and this one. It is maintained the constant current. It is not reduced when the So always maintain the constant only. So this type of the situation is known as the constant current sources, or we can say the ideal sources. Okay, what is the current source? You can see the ideal current source. In ideal current source, what is the only difference is the internal resistance is the infinity or open circuit. Then whatever the current comes, it goes to the air. But in practically, it is not infinity. So there is a high resistance connected here. So that's why whatever the current comes, some amount of the current is diverted here, and remaining current will goes here. That's why, so here whatever the source current may not be equal to the load current. So this situation is known as the real current source or a non-ideal current source, similar to the previous examples what we have studied, your father salary. Here the salary is diverted, here something deductions. Total salary from deductions, remaining salary is given to your mother. So this situation is known as the non-ideal current source. Okay. Now, however, such ideal current source cannot be obtained in practice, but higher the internal resistance of the voltage source, closer it comes to an ideal current source. This is better understand with an example. You take the similar, consider the circuit. Here, take the circuit. Assume the voltage supplied by the battery is 6 volts, just like previous one. This is 6 volts. And here the resistance is connected in the 1 mega ohms, that means so now 0.000 ohms, high resistance connected. Previously connected the 0.005, here 1000000, high resistance connected here. So what will happen if the resistance connected in this one? Then you do the calculation. Assume that the load resistance varies from 20 kilo ohms to here the 20 kilo ohms to 200 kilo ohms. It's nearly 10 times variation of the load. If the load is varied from 20 kilo ohms to 200 kilo ohms. So by changing this one, the current changes. How this value will changes, we will see now. Now, consider the two cases previously when it is supplied a current of 20 kilo ohms. Now what has happened here? This is the voltage source. Now resistance is connected. Now here it is connected. Now load is connected here. The load is equal to 20 kilo ohms. Then what is the 6 volts? What is this one? 1 mega ohms. Then as per closure law. So V is equal to IR. So I want the current. I is equal to this value. So I is equal to V by R, RT total. So V is equal to 6 volts. What is the RT? So now this resistance and this resistance connected in series. Then 1 mega ohm. So that, okay. So that is equal to 100 kilo ohms. Okay. Plus 20 kilo ohms. This one. So we are going to this one value. 6 by what is the value? So 120 kilo ohms. So we are going to very less currents flowing in the first case. This is the current. Okay, this is the current. Now that's value is equal to how much you are going to? This is equal to the current which is equal to what is the value? 6 by 120 kilo ohms. That's we are going to get the 5.9 10 to the power of minus 6 amperes. This much current, micro amperes flowing. The first case when load is equal to 100 kilo ohms only. Sorry, 20 kilo ohms in this case, 20 kilo ohms. Now load increased to second case 200 kilo ohms. Then what will happen? Say, if 200 kilo ohms here increases, okay, further increases, what will happen? Automatically that value also increased. Now you can see. In this case, the supplying current is 200 kilo ohms. Then so 1 plus 0.2 is 0.02. Now what we are going to 5 micro ohms. Here we are going to that. What was the value? 5 into 10 to the power of minus 6 amperes previous case 5.5 into 10 to the power of minus 6 amperes. What is the difference? 0.5 into 10 to the power of minus 6 value microamperes. Okay, the difference. What is the value? Well, 0.5. Okay, so now, here the change in current 0.9 microampere is taken. This is a 5.9. This is a 5 microamperes. So taking change in current is a 0.9 microamperes taking place when load resistance increases 10 times. So please remember, students, here load current increased from, what is the value? 20 kilo ohms to 200 kilo ohms. That much a variation, but change in current is only 0.09. That means so 0.9 divided by 0.0000. This much of the value only changes. So 10 times we changed the resistance, load resistance, but the current changed is only very less. So we can say this is a ideal current source. Okay. Now obviously an output current 5.9 to 5 microamperes can be considered a constant as compared to the wide variation of in load resistance from 20 kilo ohms to 200 kilo ohms. Hence it may be treated as an ideal current source. What is a non-ideal current source? That means an ideal current source means here whatever the time passes or voltage changes and the current should be constant. But in non-ideal cases, okay, non-ideal cases, what will happen? So if it increases, automatically this value decreases. This is the ideal case. This is a practical case. Due to presence of not internal resistance very high, that should be not infinity, that should be some high value. Due to the high value, some of the current diverted through this one. Hence, the current is not equal to the IS, source current is not equal to the load current. Okay, this is a basic concept. Now, when there is a large variation of the output current for a smaller or a moderate change in load resistance, so what will happen? You can see it. Such a current source may be called a non-ideal real source. In first case, you can see here, so when RL is equal to 0, that means short circuited current source. What will happen? VL is equal to 0, RL is equal to 0. Same current is flowing here throughout the circuit. When load current is increased to the some finite value R, then drop I into R, we are going to get the VR. Then whatever the load current is equal to VR, this is the current is flowing, this one. If the load resistance further increased to the infinity here, in this case, then what will happen? The current is equal to I plus 1, the voltage VL is the infinity. So that means the VL is equal to 0 initially, some resistance increases, VL is equal to VR, and further increase that VL is equal to infinity. That means here the current source may be called a non-ideal source. In other words, the internal resistance of such a current source will not a infinite or a high value, rather it will be a small value. Okay, that's why so we are going to get the small drop here, you can see it. This is a practical current source. Now conversion of, now we have seen the ideal voltage source, ideal current source. What is the ideal current source? So ideal current source is an ideal current source is a two-terminal element in which the current is completely independent of the voltage across its terminals. Whereas the ideal voltage source is an ideal voltage source is a two-terminal element in which the voltage is constant and independent of the current flows through its terminals to the load that we have seen. Now convert from voltage source to current source to voltage source. So what will happen? Any practical source, whether it may be current source or a voltage source, it drives the current through its load depend on the value of the load impedance, as we know that. So here practically we have seen that whether which type of the source you can see. So this is the current IL. IL depend upon the voltage source and resistance. So based on the load impedance or resistance, the current value changes, because we know that so I into R is both R is equal to V, and I inversely proportional to the 1 by R, both are inversely proportional. So based on the resistive values, the current will changes. So that is any practical source you can see, whether it may be a current source or it may be voltage source, it drives current through its load depends on the value of the load impedance. If load impedance, based on the load impedance, the current is derived from the EMF. Okay. Now how to convert those one? Now you can see, so here is the one voltage source and here is the one RL connected load switching, and one ammeter is connected to find what is the current in the circuit, and voltmeter is connected across the load. Okay. In constant current sources, what is happen? This source, the voltage is maintained constant under open circuit, but in real time, due to the internal resistance of the circuit, the voltage is dropped to the somewhat value. So instead of maintaining this one, the voltage is dropped. We have seen. So how the current changes, how the voltage changes, we have taken by changing the R, by maintaining the Vs is constant, by keeping the resistance low value, what is the current, what is the voltage. Further change resistance, take the readings. So by taking the voltage and current correspondingly, what is the this drop voltage across the terminals, we are going to find it here. Okay. Then this is one circuit. Now convert voltage source to current source. As we have seen that the voltage source connected internal resistance series very less value, but whereas the current source connected a high resistance in parallel to the current source. Now this is internal resistance R, small r, and voltage source. This is a small r current source. So small r voltage source is very less than the small r current source. It should be infinity value, it should be 0 value. If RV is equal RI, then we convert voltage source to current source to voltage source. So nothing will happen. So that means here any practical source, whether it may be a current source or a voltage source, it drives the current through its load depend on the its value of the load impedance, mainly depend upon the load impedance. Let us see. Now here the voltage source. Now what is the load current here? Now load current is equal to here load I. Load current is equal to what is the voltage, this value. So total resistance is equal to, you can see write it. So this is the source, resistance, this one, small or V, this is equal to R, or we can say the impedance. You can write it the impedance, or we can write it the R or impedance. This is a plus minus voltage G. So we can write it the RV or small r, we can write the ZV. So voltage source internal impedance, and this is we can say the directly we can write it the load impedance. Okay, so write it in terms of impedance because it is based on the impedance value, load impedance. Now what is the value? So as per the Ohm's law, a closed circuit, then so we are going to that E is equal to I into what is the value? That is equal to internal resistance plus load impedance. Okay, this is called, what is the current? I is equal to, we can write it, okay, I is equal, you can write it, what is the value? E by this total impedance, okay, ZL, that is the current, this is the value. Okay, now coming to the another source, here what is the current? As you know that, so what is the value? The current, so flowing, this is the current, IL, this is equal to I internal current. I want to know that what is the current flowing the circuit, this is this current I required. Okay, I calculated here this current, I got it, the load current. Now I want the load current here also. So we know that the current, total current is known, so we can write it simply, this is the current, so this is the I total current, this is internal current, we can say the I Z, we can say, we can write this is equal to I Z, this is equal to RL or ZL, we can write the ZL impedance L, this is called ZL. Okay, now we can write the IL load current. Now you know this one, as per formula, what is that one? So this current is, I require the IL, so I want this IL is required, I know the I know the impedance. This is what is impedance? Z internal and Z load. So based on this circuit, what is the circuit? You are going to write it. Oh. So here okay, this one, this is the current I, this current is equal this current I. Okay, so this is equal this current, I is equal this current. Now this is the Z impedance, ZL load impedance. The current here, the current is required, the load current IL I required. I want to know that what is the IL. So IL is equal to, we know the formula, total current into ZI into this one divided by ZI plus ZL. This is the current. So here this current is connected in voltage source and this load current is equal to this source. Now this is the equation 1, this is the equation 2. Then equation 1 and 2 is equal it. Now we are going to the same value. Then so that what will happen? This equation 1 and equation 2, that 1 is equal to, so this load, same load current we are assumed. Then substitute this value here and substitute this value here. Then what is the value you are going to get? Then we are going to get, so this is the value, that means R value, that whatever the this internal resistance equal to the here this internal resistance are equal, whether it's a current source or voltage source is equal, then what will happen? So we can convert voltage source to current source. The internal resistance is same, equal, so conversion. Okay, So here previously we assumed that this is a very high, this is a very low, but in conversion, the load current point of view, impedance, that is dependent on the resistance value. The current through the circuit is dependent upon the impedance of the load. So now load current we calculated in current source, load current connected in calculated in voltage source. So by equating this load currents for the same loads, then we are going to get that the internal resistance in a voltage source is equal to the internal resistance in a current source. That means if you are connected internal resistance in series to the voltage source, that should be very low. If same the resistance, if we are going to connect it in current source, that should be connected in parallel. That's why it should be increased very high. The value will change. When it comes to the voltage source, the value will be less, but it is connected in series. When it is connected to the current source, it should be connected in parallel. That should be value increased to the very high. So we have seen this one. So now we can convert voltage source to current source. Okay. So how we are going to convert? So here the values. So both we are going to convert. Let us see that one. Now for example here, so voltage source is given here, that is called Vs and some resistance. So internal resistance, this is the source. Okay. Now we are going to connect the some load. So we can say this is called voltage source impedance value, internal impedance V, this source. Now whatever the value here is converted to the current source. So this is equal to the voltage source, the plus minus, okay, plus minus converted to the current source. This source is converted, this value, okay, this value is converted into current source. Here plus minus, similarly top, you remember that signal, plus minus. Now this one connected with parallel to here. Now this equal to this. Now you are going to load. Okay. So what is the value of this one? Just whatever the value, you convert the current V by Z, we are going to get that value. So what is the V here? Vs. What is this one? Z V. So that converter V by Z, ohmic value by this one current source, that are the equivalent values. Now what is this value? That is equal to Zi. So whatever the source is given, here you can see whatever the source is given, okay, whatever the source is given here, the source is voltage source is converted to the current source, and the value whatever the Vs is given, what is this one? From these two values I converted Zs by this value, equivalent of current source, and the resistance which is connected in series in voltage source is converted to the Z source here. Same equivalent, because previously we have proved that the internal resistance are equal in voltage source and current source, but the placement is different. So this circuit is equivalent to this circuit. This is now the voltage source is converted to the current source, vice versa it will takes. Okay. Now let us see now how your current source is converted. Now we can see here, for example, there is a current source. Okay, this value is equal to high source. Now as we know that there is a parallel internal resistance, that should be Zi. Now we are going to convert this is we are going to load. Okay, this is the current source. Now this is equal to whatever the voltage source, the current source convert to the voltage source. Now we convert same, this is So, direction plus minus, take it simply, whatever this one you connect in series. Now, this is the one you connect the load resistance. So, what is the values here? Because IS, current is flowing IS, this one. Okay. So, now we convert, that is equal voltage V is equal I into R. So, I is equal to this one, R is equal to ohmic value, this one. Then this value voltage source Vs is equal to Is into Zi. This is a value. Now, what is this value? Simply Zv. What is the value here? The substitute here. This is equivalent voltage source. Okay. So, this type of the conversion is required while simplifying the network theorems. That is why, so we are going to concentrate on how to convert voltage source to current source to voltage source. The internal impedance values are same, but whereas the current is converted to voltage based on the Ohm's law, just to substitute the values. Okay. These are the methods you should know. Now, so this is called source conversion technique. It is useful in network theorems. Okay. So, dear students, now we have learned few new techniques in network theorems in second lesson. What is the energy sources, ideal voltage sources and ideal current sources, and what do you mean with the ideal voltage source? An ideal voltage source is a two terminal element in which the voltage is constant irrespective of load changes. An ideal current source, it is also two terminal element in which the current is completely independent of voltage variations. But it's practically the voltage source also having some internal resistance in series very low, hence it may not be constant source voltage when load changes at terminals. Similarly, current also. Now, we have seen the conversion of voltage source to current source purpose, because we know that any practical source, whether it may be voltage source or current source, it drives the current through its load, depends on its load impedance. So, load impedance plays a vital role to flow current in a network. So, based on this one, we proved that the internal resistance connected in voltage source in series is equal to the internal resistance connected in current source in parallel equally. So, we converted given voltage source into current source and current source into voltage source. Okay. So, these are covered in this class. So, dear students, if you are having any doubts, so we will clarify in the next class. So, thank you for listening.